Okay, so in this particular section, we're going to talk about savings plans. And we start, fortunately or not, with this very scary looking formula. I'm just going to call it what it is. Um, Luckily, a lot of the variables are already familiar to us. Um, let's see, let me kind of go through what they mean with respect to a savings account. So A, we refer to as our accumulated savings balance. So accumulated, which means the amount we had at a certain time. Accumulated savings balance. The amount we have in our savings account. How do you like that? PMT stands for a regular payment. So regular payment or deposit. And what this means is we plan on setting aside the same amount of money each month. So say I'm going to set aside 50 bucks a month into my savings account. How much money, assuming the interest rate stays the same and I'm able to stick with the $50 a month, how much money would I have in my savings account at the end of 10 years or 20 years or something like that? APR stands for the same thing it's always stood for. That's annualized annual percentage rate. N is the number of payment periods per year. So it's kind of like if we compound annually versus compound semi-annually or compound monthly. When we're talking about that in terms of loans, this time we're talking in terms of savings accounts. So if I plan on making the same payment each month, then N in this case would be 12. If I plan on making the same payment each week, then it's 52 weeks in a year. So N in this case would just represent the number of times that I plan on putting that constant amount in my savings account. And then Y would stand for number of years. Okay, so it's not hard to set up, but it does require a little bit of calculator common sense, I would like to say. So we'll kind of set this up and kind of go from there. So we use a savings plan formula to calculate the balance after 6 months for an APR of 12% and a monthly payment of $100. So I would like to know at the end of 6 months how much money's in my account if I plan on just putting $100 in each month and I earn 12% interest per year. Okay, so we'll set this formula up. I start off with a $100 payment, and then it's 1 plus annualized percentage rate is 0.12, but that's an annualized percent, so I got to divide that by 12. And I want to raise that to the fact that it's 12 times a half. Now, the half comes from the fact that I'm only doing a half of a year, so I'm only doing 6 payments instead of 1. Minus 1, okay, and that's the numerator. And the denominator, I got 0.12 divided by 12. Okay, one thing that's going to help do this in a calculator correctly is to, sorry, I just noticed I'm missing a parenthesis there, is to rewrite common decimals that show up a lot through the problem and try not to, what I like to call, show off with your calculator. You do not have to do this in one step, so please don't feel obligated to just start going to town with parentheses. You really do want to take some time and write out each of these different steps. So I'm going to rewrite this before we actually get our final answer. I'm going to start with that 0.12 divided by 12, and I get 0.01. So that's something I can simplify in my calculations. So 100 times 1.01, and then 12 times a half is 6, and then that piece is minus 1, and then divide that by 0.01. Okay, so let me go back to my calculator, and again we're going to do this in pieces. So out 1.01 raised to the 6th power gives me that number. Subtract off 1, and I'll get the 0.06. Now I want to multiply that by 100, and then divide by 0.01. And I end up with 615.2. So 12% a year, if I let it sit there for 6 months, I might just keep putting in $100 a month, then I'd have $615.20. An annuity is any series of regular equal payments. Any regular equal payments. So in the previous example, we were putting in $100 a month. So that $100 we refer to as the annuity. An ordinary annuity is a savings plan in which payments are made at the end of each month. Okay, yeah, it does matter when the payments are made. So if we say we're paying it at the end of the month, we call that an ordinary annuity. Okay, if we happen to pay at the beginning of the month, we refer to that as annuity due. Future value of an annuity is the accumulated amount at some future date. It's the amount in the account in the future. Present value of a savings plan is a lump sum deposit that would give the same end result as a regular payment into the plan. Okay, so let me say that one more time. Is a lump sum deposit that would give the same end result as regular payments into the plan. So present value is if I was to put in one amount of money that would have the same as putting in the regular payments, then what's the present value of that? Okay, so a present value of a savings plan is a lump sum deposit that would give the same end result as regular payments into the plan. Okay, so we want to think of it as a lump sum that would equal the same result, same end result, same end result as regular payments into the plan. Okay, so what would the big chunk of money be that would be the same as if I paid the same amount every month or however often we're paying in the account? Okay, all right, let's dream a dream for a second. So it turns out that there is a certain amount of money that if you have it sit in the bank, you're going to earn interest. And it's possible that you can live off the interest and never touch the original principal. So let's go through a scenario about what would this magic amount be. So suppose we'd like to retire 25 years from now and have a retirement fund which we draw an income of $50,000 per year forever. In other words, I want to have a magic amount in my account that 25 years from now, I know I can just keep taking 50 grand every year and never deplete the amount of money that's in there. So how do we do it? And based on the idea that we need a 7% APR. Okay. Well, let's start with this magical total balance that I don't know what it is yet. I know that I want $50,000 should be 7% of the overall account. So if I take the 50,000 divided by 0.07, I should end up with $714,286. In other words, if I just let $714,000 sit in the account, or 25 years from now, if I have that amount in the account, then I can just keep drawing 50 grand every year, and I would be able to live off that 50,000 and never touch the original balance.